Thank you everyone. Today I discuss about combination of resistances. What do you mean by the combination of resistance? When two or more than two resistors are connected in a single electrical circuit, then this connection, this arrangement is known as combination of resistances. Here the resistances are connected in circuit in two ways. Number one, in series connection, and in number two, in parallel connection. So combination of resistances are two types. One is the series combination, another is the parallel combination. Except these two, there is another combination which is known as mixed combination, where series and parallel both combination are mixed in a single circuit. These are the three types of combination. Here we discuss about series and parallel combination. First of all, series combination. What do you mean by series combination? Here, two or more than two resistors are connected end to end. That means first resistor is connected with the second resistor is connected with the third resistor, and so on. Say here is the first resistor. Here this is the first end, and this is the first end, and this is the second end. This second end is connected with the second resistor. This is the second resistor. This is the second end of the second resistor. This second end is connected with the third resistor. It is the first resistor R1, it is the first resistor R2, and it is the first resistor R3. That means resistors are connected end to end. And at last, the first end of the first resistor and the second end of the last resistor is connected with the source of electricity. This type of combination, this type of arrangement of the resistors is known as series combination. Here the series combination, only there is the one branch in the circuit. So circuit current, say it is I, it flows through each of the resistance. Here the current is I through R1, also I, that current through R2 is I, and current through R3 is also I. That means through all the resistances, the same current flows through them. But the potential difference across the different resistors are different. Say for the first resistor, the potential difference across that is say V1. Potential difference across the second resistor, say it is V2, and it is R3. That means potential difference across the third resistor is V3. This V1, V2 and V3 are not equal. if the potential difference across the total circuit is V, then V is equal to V1 plus V2 plus V3. This is that means in the series circuit, potential difference of the circuit is divided against the all resistors. That means potential difference is divided, but current through them are same, and the resistors are connected end to end. This is the series combination. Now take the another combination which is known as parallel combination. What is the parallel combination? Parallel combination. Here the one end of each resistor is connected at a one point. Other ends of the each resistor is connected to the another points. That means, say it is the first resistor, it is the R1, it is the second resistor, it is R2, and it is the third resistance resistor R3. This end all the are connected at a single point, say A. Other ends are connected at the other end B, at the separate point. One end of each resistor is connected at a single point, and the other end of the resistors are connected at the another point, and these 2 points are connected with the source of electricity. This combination is known as parallel combination. In this circuit, the circuit is divided in the various branches. So the circuit current I is divided here in the various branches. According to this figure, in the 3 branches is the I1, is the current through this I2, and current through this is I3. That means this circuit current is divided into 3 branches here. That means here the I is equal to I1 plus I2 plus I3. So here the circuit current is divided through the different resistor. But 2 ends of the every resistor is connected with the battery directly. Say R1, its 2 ends is this. These 2 ends is directly connected with the cell. This is the second resistor. This is the 2 ends of the second resistor, and it is also connected with the cell directly. Third also connected with the cell directly. As all the resistor connected to the cell directly, so all the resistors have same potential difference across them. That means if the circuit have potential difference is V, then R1 also maintain the potential V, and R2 also maintain the potential difference V, and R3 also maintain the potential difference V. That means in the parallel circuit, potential difference of the circuit is not divided, but the circuit current is divided. This is the parallel and the series combination. Now here we now discuss about the equivalent resistance. What do you mean by the equivalent resistance? First of all, you take a circuit. This is a series circuit. This is a series circuit. This is the R1, this is R2, and this is R3. And say the circuit current is I. Now, if we replace these resistors from the circuit and place a single resistance in such a way that the circuit current remains unaltered, that means remains I. That means if say if this point is A and this point is B, we take this is the point A and this is the point B. Now this three resistance is removed, and in place of this we take a single resistance, say R, for which the circuit current remains unaltered, that means I. Then this R, that means equivalent resistance. This is known as the equivalent resistance of R1, R2 and R3. Now what will be this value? Mathematically we can prove that this equivalent resistance R is equal to R1 plus R2 plus R3 plus, if another resistance is there, plus dot 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 dot, so on so on. So equivalent resistance of the series combination are the sum of the component resistors. Now we discuss this equivalent resistance for parallel circuit. Parallel circuit, that means say this is a first resistor, this is the second resistor, and this is the third resistor. So all this is the point A and this is the point B, and it is connected with the cell. This is R1, this is R2, and this is R3, and circuit current is I. This is a parallel combination. Now you remove this arrangement. Remove this arrangement from here and put a single resistance here in such a way that the circuit current remains unaltered, it is I. That means this is the point A, this is the point B. With that there is a cell, and at the point within the point A and B, remove this and put a single resistance here. In place of R1, R2, R3, you put a single resistance R in such a way that circuit current remains unaltered I. Then this resistance, this single resistance, is known as the equivalent resistance of R1, R2 and R3. Now how you calculate, how you know what will be the value of this equivalent resistance, or what is the relation between this equivalent resistance and R1, R2 and R3? It is a 1 by R, that means 1 by equivalent resistance, is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and so on so on. If there is a more than 3 resistance, if there is more than 3 resistance, then it will be plus 1 by this, 1 by this, 1 by this. This is the by this formula you can calculate the equivalent resistance of the parallel circuit. So equivalent resistance of the series circuit was R equal to R1 plus R2 plus R3, and for the series circuit it is 1 by R1 plus 1 by R2 plus 1 by R3. In the series circuit it will be R equal to R1 plus R2 plus R3. This is for series circuit. and it is for parallel circuit. This is the ultimate series connection and the parallel connection. At the next video, I discuss briefly what is the how you get R equal to R1 plus R2 plus R3, and from parallel circuit how you get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, and also in details about the series and parallel combination. Thank you.